Previously, we had defined Coulomb's law in scalar form. We came across one such property of charges where we said that charge is a scalar quantity and charge does not have any direction. It is true, but when we define the interaction between the charges, they come across one such phenomena of repulsion, also attraction, such that it is giving rise to one more force. So when we talk about a force, then we have to talk in terms of vector quantity, because we want to know where the force is acting, whether the force is acting on the opposite direction, whether the force is acting on the same direction, or whether the force is acting on this direction, because a force has a direction. Hence, in order to know the direction, we need to take the help of vectors, because a vector gives you the direction as well as the magnitude. Just like the previous case, in this case we are taking two charges into consideration with an origin O. R1 is the position vector of Q1, R2 is the position vector of Q2. This force F12 is the force acting on Q1 due to Q2, and the force F21 is the force acting on Q2 due to Q1, such that the formula becomes F12 is equal to 1 by 4 pi epsilon naught Q1 Q2 divided by R12 square with a unit vector of R12. Similarly, for F12 it becomes R21 square with a unit vector of R12. From your class 11, the definition of unit vector, we have R12 as R12 divided by the magnitude of R12. Similarly, for the unit vector of R21, it becomes R21 divided by R21, the magnitude of R21. So, in this particular case, where the force is acting on Q2 by Q1, then it becomes R12 is equal to R1 minus R2 for the force acting on Q2 by Q1, which is for this particular scenario. And similarly for F21, where the force is acting on Q1 by Q2, then it follows R21 is equal to R2 minus R1. And this is the case for this particular formula. So this is the vector form of Coulomb's law. So out here in this particular case, these are two like charges. So if you have two like charges, Q1 and Q2 are like charges, then it is a positive quantity. And if you have Q1 and Q2 unlike charges attracting each other, then it is a negative quantity. Hence, from Newton's third law, R21 will be equal to negative of R12. Therefore, the force on 1 due to charge 2 will be equal and opposite to the force on Q2 by Q1. We have to remember two notes, that the electrostatic force is a conservative force, which means that the work done by the electrostatic force over a closed path is zero. And second point is, electrostatic force is a central force, which means force acts along the line joining the center of the two bodies. Hence it is known as the central force. And conservative force because the work done by the electrostatic force in a closed path is zero. So this is your Coulomb's law in vector form.